This video demos some of the functionalities of AutoETF, a tool for extraction of traceability links between test and code artifacts in embedded devices. This tool currently supports the Blackfin processor from analog devices and integrates well into the development platform Visual DSP++. For more information, please refer to the Software Quality Research Group at the University of Calgary. What is currently shown is the Visual DSP software. On the top are the menu of the tool. Note that our testing framework adds additional menu entries with the denomination A unit for embedded unit. On the center left, a file navigator shows our test files. Those are the files we wrote to test a car gear controller system composed of an engine, a gear, a transmission, torque parameters, and vehicle dynamics. Additionally, there is other classes responsible for the logic of shifting and threshold of the car. The editor window on the right shows two tests for a product function used by the transmission to compute the effect of gear between engine and wheels. On the bottom, a console shows output at execution. Bottom right is a dedicated A unit window which expresses the outcome of tests. Now we run the test and the two windows on the bottom are updated to show the result of tests. S stands for success, F failure, and F for expected failure. Now I will open the file on the test, the transmission gear ratio, and the specific function on the test called product. Each of the functions that build this car system has an annotation to their requirement. In this case, the following three use cases that describes the functionality of the system: update engine RPM for rotation per minute, and change gear. In the next part of this demo, I switch to another tool called Doxygen. Doxygen is an open source project to build documentation from source code based on annotation. In this project, this tool helps us to link source code to requirement. In the tool, we select the type of input Javadoc autobrief for the format of our annotation and optimize output for C for the language of file we parse. Next, we select the output format. This format will be used to build link between source code and requirements. Therefore, our choice went naturally to an XML format to simplify this process. The configuration process is finished. Let's now run Doxygen to generate this XML documentation. The next step goes back to Visual DSP and our integrated extension A unit. By opening the eUnit eRecover window, we now select the files we want to compute the code coverage report and build a traceability XML file with links between test code, source code, and our use case requirement. Let's select transmission gear ratio and test from the previous test and source code. Those files were shown in the editor previously. We now generate the report for the code coverage and traceability. This takes some time and is accelerated in this video. This parses our data and XML file to produce our XML traceability files. This XML file organizes our data optimized for graph representation. All artifacts, test, source, and requirement are represented as nodes of a graph using an XML node balise, and their links are edged with an XML edge balise. Those edges connect nodes together and form the traceability links. Those data can be used by an external tool or loaded by our graph visualization tool. We hope you enjoyed this screencast. For more information, please refer to our website. Thank you for watching.